All right, let's jump right into this explainer and tackle one of the most fundamental challenges for financial analysts today, comparing data across the rapidly growing, incredibly diverse wind energy sector. When you're looking at sustainability in financial data, raw numbers rarely tell the whole story. To actually understand how a company is performing, you need a baseline, you need context. So today, we're going to do a quick financial summary of the foundational activity metrics used for data normalization across the wind industry.
We're starting with the ultimate problem in ESG investing. Picture this. You're looking at two different wind project developers. One is a massive global corporation installing hundreds of offshore turbines every single year. The other is a smaller, local developer focused on specialized onshore community projects. If you just look at their total raw materials used or their raw number of safety incidents, well, the global giant is always going to look worse simply because they're bigger. Understanding that comparing absolute numbers between a massive corporation and a smaller local one is quite literally like comparing apples to oranges, is step one to better analysis.
So what's the fix? Well, the solution provided by the SASB standards is something called activity metrics. You can think of these as the great equalizer for industry data. They're specific data points designed to quantify the actual scale of a company's operations. They give us our denominator. By dividing raw sustainability data by these activity metrics, we transform those raw numbers into normalized rates or ratios. And really, this is the only way to facilitate a true, fair comparison between companies of vastly different sizes.
Section 1. Foundational Industry Activity Metrics. Let's see how building this framework works specifically for wind technology and project developers. The SASB standard actually anchors our entire analysis into 4 specific foundational metrics. We've got the number of delivered wind turbines, the aggregate capacity of delivered wind turbines, the amount of turbine backlog, and the aggregate capacity of turbine backlog. These 4 metrics are the absolute bedrock of any serious financial and operational summary of a wind technology company. And what's brilliant here is the dual lens analysis. Those 4 metrics require us to evaluate the business from 2 distinct but highly complementary perspectives. On one side, we have the financial accounting scale, which is measured in the company's presentation currency, and then on the other side, we have the physical sustainability scale, measured in megawatts. You absolutely must look at both of these to understand the true trajectory of a wind developer.
Section 2, Tracking Turbine Order Backlog. We're going to look at this chronologically, starting right here with the future pipeline.
The standard requires companies to report their backlog using both of those lenses we just talked about. Metric C tracks the backlog in the presentation currency, so the financial value of the unfulfilled orders. Metric D tracks the aggregate capacity of that exact same backlog in megawatts, meaning the physical power generation potential of those future turbines. By tracking it both ways, analysts get a standardized, 2-dimensional view. You don't just see how much money is coming in, you see exactly how much physical wind power the company is actually contracted to build.
Now here's a crucial point. This metric focuses purely on hardware and project development. The standard is very explicit. You have to completely strip out any backlog amounts resulting from operating and maintenance agreements, or any other service agreements. Why? Because O&M is a totally different business model, right? It has a completely different risk profile. To keep the data perfectly clean and comparable for manufacturing scale, the backlog metric has to remain strictly focused on the turbines themselves.
Section 3. Measuring delivered wind turbines. Now we transition from the future outlook into the realized present.
This is the natural life cycle of the business. An order is placed and sits in the backlog. Then it moves into the resource-intensive manufacturing phase, and finally, it transforms into a tangible physical delivery. Tracking the volume at this final stage gives us the denominator for all the impacts that occurred during manufacturing.
Just like with the backlog, measuring deliveries requires a dual approach. Metric A simply counts the raw number of delivered wind turbines. But, as you probably know, wind turbines have grown incredibly massive in recent years. We are talking about structures taller than the Statue of Liberty. So, a company delivering 52 megawatt turbines is a totally different ballgame than a company delivering 50 10 megawatt behemoths. That's why just counting the raw number isn't enough. You've got to pair it with metric B, the aggregate capacity in megawatts, to truly understand the sheer scale of the power generation delivered to the grid.
To maintain absolute precision here, the standard requires that both the number and capacity of these deliveries be broken down by specific wind turbine classes. These are strictly defined by the International Electrotechnical Commission, or IEC, 614001 design requirements. The class is determined by the turbine rating, like Class I, II, III, IV, or Class S. This granular breakdown is great because it prevents companies from masking the true nature of their deliveries.
Section 4. Why these metrics matter. So why do we go through all this trouble to measure backlog and deliveries by currency, megawatts, and IEC class? Let's see some normalization in action.
Take workforce health and safety, for instance. The wind industry involves inherent physical and electrical hazards. If a company reports 10 injuries, is that a good year or a bad year? We honestly don't know without the scale. Under the standard, injury and fatality rates are calculated against a normalized baseline of 200,000 hours worked. That specific number represents 100 full-time workers putting in 40 hours a week for 50 weeks a year. Using that lets us fairly compare safety records across companies of completely different sizes.
And it's the exact same logic for environmental data. We use physical activity metrics like megawatts of capacity to normalize it. For example, looking at the total metric tons of steel a company consumes tells you absolutely nothing about their efficiency. But when we take the mass of the turbine's top head and divide it by the turbine capacity in megawatts, boom, we create an apples-to-apples ratio, metric tons of top head mass per megawatt. It clearly reveals which companies are actually innovating to produce more power using fewer raw materials.
Without these foundational activity metrics acting as your denominator, whether it's total hours worked, delivered megawatt capacity, or the currency value of the backlog, raw sustainability data is quite frankly just noise. Which leaves us with one final, pretty critical question for your next portfolio review. If your data isn't properly normalized, are you actually analyzing a company's efficiency, or are you just admiring their size? Keep these SASB activity metrics in mind, and you'll cut through the noise every single time.